Hi there. Today we will graphically resolve one more system during our lesson. Recall, to solve the system graphically, we need to create the graphs of the functions one by one and find where they cross. In case the graphs intersect, the coordinates of the intersection point will represent the solution to our system of equations. In the case that the graphs do not meet, then the system of equations has no solutions. Or, if we draw the graphs of the functions and they overlap, then the system of linear equations will have a multitude of solutions. You can also solve the system using other techniques. We talked about and solved the system of equations using substitution and addition methods. However, you must learn to solve the system using graphical methods. I want to emphasize that if we are searching for the intersection point, we need to graph these functions. But there is indeed another method to find the intersection point of a function's graph. However, in today's lesson, we will plot the graphs and find the points of intersection. To do this, we express the variable y in each equation in terms of the variable x. First equation, 2x plus y equals 8. From this equation, we can derive that y equals 8 minus 2x. 2x's were shifted right with a minus. Now let's graph this function. This function is linear since it involves the variable x and y are both to the first power. Thus, we only need to determine the coordinates of 2 points. These points are set freely. You can choose any point, any value for x, and find the corresponding y value. But I recommend choosing values that will be convenient for calculations. The first value is x, which is 2. If I substitute 2 for x, I will get 8 minus 2 times 2. That's 8 minus 4, which equals 4. When x equals 2, y is 4. Another point. Let's take the value for x equal to 4. If we replace x with 4, we have 8 minus 2 times 4, resulting in 8 minus 8. Then y will equal 0. As a result, we have 2 points. The first point is 2, 4, and the second point is 4, 0. I want to draw your attention to the fact that you may get different points, but in the end, you will have the same straight line graph. Despite the fact that these points may be located somewhere else, if we extend this line further, we will ultimately obtain the graph of this very line. But we specifically took the value of x equal to 2 and found the value of y. And for x equal to 4, the value of y is 0. We will denote these points on the coordinate grid. The first point is at 2, 4, 2. At x2, and 4 times 2, 3, 4. As a result, the point with coordinates 2, 4 will be found in the first quadrant. The second point is 4, 0. We begin our movement. First, the coordinates 4. We proceed to the right. 1, 2, 3, 4, and 0. We stop at this point. And now we will join these 2 points. These constructions must be done with care. Y is equal to 8 minus 2x. This is the graph of our first function. The second function is 2x minus y equals 0. We need to express the variable y. Let's write it down. Minus y equals minus 2x. Get rid of the negative value of y. So we will multiply by -1. and as a result, we will have y equals 2x. Likewise, for this function, we assign the value of x. The first value is 0. Then y is equal to 2 times 0 is 0. The first point is 0, 0. And the second point, let's choose. Instead of x, the value equal to 1 unit. And if I substitute 1 for x, then y will equal 2. And we will make 2 more points. The first point has coordinates 0, 0, and the second point has coordinates 1, 2. We will plot these points. The first point is at 0, 0, and the second point is at coordinates 1, 2. Let's draw a straight line through these 2 points. And this line will represent the graph of the function equals 2x. And we see that the graphs of these functions intersect at some point. The coordinates of this point will be the solution to our equation system. We must find the coordinates. We extend a perpendicular to the x-axis. The x-coordinate is 2, up, and we go to the y-axis, or we find the coordinate of this point, and the coordinate of this point is 4. We got a common point with coordinates equal to 2, 4. Therefore, if we have a point with coordinates 2, 4, then this pair of numbers will be the solution to our system. This answer can be written as follows: x equals 2 and y equals 4. This pair of numbers will be the solution for our system. Let's check. If we substitute 2 for x and 4 for y, we get 2 times 2 plus 4. 2 multiplied by 2 is 4. 4 plus 4 is 8. So this number pair is the solution to the first equation. But if the condition states a system, then this pair of numbers must also be a solution to the second equation. Thus, we will substitute x with 2 and y with 4, and then we will compute. 2 times 2 equals 4, and 4 subtracted gives 0. So this point is also a solution to the second equation. So we claim that the pair of numbers 2 and 4 is a solution to our system. I would like to point out that we are creating graphs of linear functions. In this case, they may have one point of intersection, or there could be no intersection points at all, or even 2. Lines may coincide, but if you consider a system of nonlinear equations, in this case, the graphs of the functions can intersect at more than one point, and then the solution can be 2, 3, and so on. Next time, we will tackle another system of graphical equations. For now, our lesson is over. Farewell, until next time.